Welcome to the Infinite Jungle. I am here with Robert Miller, the product lead and steward at Flashbots. Thanks for being on the show.
Thank you for having me.
I am very excited to get into all things MEV with Robert today. And this is also probably the second episode on Infinite Jungle where we actually have a in-person guest. So I'm very happy about that.
You did kind of rug me on the jungle theme. So.
I did, but I was relying on you. I knew that you were going to be a good guest and wear something jungle themed, even though I wasn't. So thank you for that. We are going to be talking about all things MEV. For context for this episode, we are not really going to be going into the basics of MEV, what MEV is. We're really going to dive into the latest, kind of most cutting-edge conversation about MEV, look into the future of MEV. So if you want some background or context about it, take a look at the reports that I've written about MEV and going over the basics of MEV. We'll link that in the show notes. So before we start the show, as always, here is a quick show disclaimer. I need to remind you to please refer to the disclaimer linked in the podcast show notes and note that none of the information in this podcast constitutes investment advice, an offer, recommendation, or solicitation by Galaxy Digital or any of its affiliates to buy or sell any securities. So, Bert, back to the show. Bert, there is quite a lot of controversy and quite a lot of discussion among Ethereum developers, I think, about what it means for Ethereum to move into a more rollup-centric roadmap. This does fragment the user base of Ethereum quite a bit. It fragments the liquidity of Ethereum quite a bit. But there's also a ton of questions about how this rollup-centric modular roadmap is going to impact the MEV ecosystem. This MEV supply chain that we have, from searchers to builders to relays to validators. Can you talk a little bit about how MEV works in Ethereum's new roll-up-centric model and vision?
Of course, yeah. And it's a good question. Interestingly enough, I feel like there's not all that much discourse about this online. I don't think you can read anything about MEV and L2s as an example. So I'm happy to have the chance to talk about it with you today. The first thing to note is that in a more modular stack, MEV doesn't go away or something like that. It just sort of shifts around depending on the choices that you're making in your stack. And so with a standard rollup, as you would expect it, MEV is kind of dictated by the sequencer, who's the party that orders transactions, decides what gets included in a block. There are other kind of choices that you could make, and so there's the notion of a based rollup as an example, where the sequencer is actually an L1 proposer as well. And MEV still exists there. It's just the L1 proposer is deciding what gets included in a block, even on the rollup. And so the L1 proposer has MEV rights in that context. And so regardless of the choice that you make, and there's a lot of different variants of the modular stack, regardless of the choice that you make, it's just some other party kind of has MEV control. And the dynamics change a little bit. But MEV does exist in this world too. And I think the most interesting question for me right now is this relationship between MEV and performance of these chains. That's one thing. And then we can also talk a little bit about how performance and composability work as well. And to go one level deeper into what I mean, in the L1 context, we have on average 15 million gas every 12 seconds. So it's about 1 million gas per second. In the L2 context, I think base blocks right now go up to 5 million gas per second. And there is the stated goal of let's get to a gigagas per second, a billion gas per second. And so we want to go somewhere between 1,000 to 200x in multiples of throughput in performance of these systems in order to scale. And already we are seeing that the MEV dynamics on L2s look very different than L1s because of this different kind of performance setting. So with a really fast chain and a private mempool where fees are really cheap, the dominant strategy for a MEV searcher is to do your searching in a smart contract on-chain and to try to probabilistically capture MEV by sending a lot of transactions that perform your MEV searching, again, in a smart contract, and they revert if they're not able to find any MEV.
Basically like spamming the chain with transactions, trying to get one of them into a block.
Exactly. So you spam 100,000 transactions, literally 100,000 transactions. 99,999 will fail, and one of them will succeed. But since the cost of a reverting or failed transaction is 1 cent or below, and you can make 50K, 100K, sometimes more if you're lucky on your ARBs, this ends up being profitable for the searcher to do. And so the kind of revealed dominant strategy of MEV searching on L2s right now is to spam the chain super hard. And a lot of these transactions on L2s, a lot of the gas used is actually from MEV searchers reverting on chain. And that's at the current scale, right? And we want to 200x where we are today at current scales. And the incentive for searchers is going to continue to be to try to spam and capture ARBs probabilistically in this way. And so this problem is only going to get worse from where it is today. And I would ask yourself, if we get to 1 billion gas per second, but 999 million of these gas is spent by MEV searchers who are reverting on chain because it's basically costless to do so, was that really successful? And can we handle that type of scale of MEV activity? You've seen in a bunch of ecosystems, I'm sorry this answer is a little long, but you've seen in a bunch of ecosystems where we're not able to handle that kind of load. So rollups, a couple different rollups have had cases where they are spammed with a bunch of transactions in a really isolated case that'll take down the sequencer. Solana also has had trouble handling MEV and transactions made at this scale. And so you need, I think, as a part of rollups wanting to scale and get to higher performance, you need to do things that help mitigate the impact of MEV and have more MEV-aware transaction ordering. But it probably won't look like what it does on L1 as well, because at 1 billion gas per second, it's really hard to build a full block. It's not clear that you could do the same thing that we're doing for the Ethereum mainnet just at 1,000x the scale of what exists today.
And why is that? Because if you
just the raw kind of technical performance of the state-of-the-art block building infrastructure that exists today, it's not clear to me that we could throw 1,000x more compute, more gas at the system, because even if you are processing blocks that are 1,000x larger, there's a lot more computation that goes into finding that block than like the naive sequencer. So to do block building for 1,000x more gas in a block, maybe you need to do 1 million times the computation that exists today.
I see.
And it's not clear we have the actual technology to do that right now. But you may need to address MEV and have MEV-aware auctions in order to hit higher gas performance on these chains. And so there's this interesting trade-off between how performant can we get, how are we addressing MEV, as well, that I think is not really figured out yet. But you need to address MEV if we are really going to scale these rollups.
Yeah. Well, okay. So a couple of questions there about that future where you have a bunch of MEV being earned on L2s, which seems to be the case as L2s, the DeFi ecosystem on L2s grows, the user trades that are happening on L2s becomes a lot more valuable, lucrative for people to front run, back run, sandwich. The kind of congestion that's happening in the mempool, very similar to what had been happening on Ethereum during DeFi summer before we had MEV Geth, before we had that separate auction, kind of off-chain marketplace for people to be submitting their bids. If there are clearly players that have the hardware and have the software to be able to identify and be able to simulate different kinds of transaction bundles, should there just be an off-chain marketplace similar to what we have on Ethereum for all of these L2s, or maybe just one that kind of lives between all of them, like a cross-chain almost MEV-Boost place? Are there relays? Are there kind of marketplaces that are being built to that end? Is that the solution that you envision to solve the problem of spam on these L2s, kind of like what we did for L1?
I think that you do want something like an MEV auction for L2s. And so your choice may be, do you want 1 billion gas per second, where 99% of that is used by MEV searchers that are reverting on chain looking for MEV probabilistically? Or do you want a little bit lower gas per second, but you get MEV revenue, because right now these searchers are taking home most of the MEV, and you get less wasted block space, so you have more available for users, but you may not be able to push it to 1 billion gas per second. And I think that may end up being what the trade-off is you can't just push performance to infinity. You need to accept some sort of limitation in order to actually get more block space that's available for users by having this smarter off-chain auction. And we're still kind of navigating what that trade-off is exactly, and what the relationship between being more MEV aware and high performance is. The one thing that I'll note is that even if you have an MEV auction, it probably won't look exactly like it does in L1-2, which I think is another thing that you were asking.
You were talking about trade-offs between performance and then the scalability. Are there also trade-offs in this dynamic that are perhaps different from the L1 when it comes to decentralization and versus centralization? Because with rollups, especially centralized ones that have a single sequencer, it doesn't seem like MEV is too big of a problem if you can make the sequencer or basically like adjust how the sequencer works, that one sequencer, because it's a centralized sequencer, and they're the ones who ultimately control what transactions get into a block in what order. And if they don't give up that right, then maybe there is some tools that can help that sequencer figure out how to deal with the MEV and the spam activity happening on their chain. And there doesn't really seem to be a ton of rollups right now that have a lot of decentralized sequencing really happening. It's a little bit of a future, like maybe one day in the future. I mean, a lot of people are working towards
on
it.
The roadmap.
On the roadmap.
Yeah.
So are there trade-offs there in the sense of like the necessity of building products for rollups that have centralized sequencers versus decentralized, which is where the ball is heading? What are some of the trade-offs about like trying to create an MEV ecosystem that is, again, transparent and open and trending towards more decentralization over time?
Yeah. There's a lot there, but I don't think it looks like a copy-paste of L1. That is for sure.
Okay.
So, today on L2s, users expect private mempools, and nobody likes the UX of being sandwiched. And so L2s want to keep that experience regardless. And so that's one notable difference. And to your point, in the L2 context, there is generally there's a lot more centralization than we expect at L1. And so maybe you can impose kind of more social restrictions on your MEV ecosystems. You might want external block builders, but you might have the requirement that they don't sandwich, right? And I think that's very reasonable. You also generally trust the proposer in this context, the sequencer, a lot more than we do on L1, because not anyone can spin up an L2 sequencer. And so you don't necessarily need relays to mediate the relationship between builders and sequencers too. You can probably get away with trust in that context as well. One thing that a couple things that we've been thinking about in this context is if you can use the builder to give really fast pre-confirmations also. And so we have this state-of-the-art trusted execution environment building infrastructure where inside of an SGX or a TDX, the sort of latest version of trusted hardware from Intel, we're doing block building, and you could have that block builder tell users, here's the latest state of the chain before the block is actually included on chain. And since it's inside of trusted hardware, you know that that builder is not going to go back on its promise made to you. And so you can take something like 1 second blocks on a rollup and turn them into a much lower latency experience as well. That's one thing. The other thing that we have been exploring is, can you allow builders to co-locate their code inside of an SGX and then restrict what they can do inside of it? And so a rollup may only permission these SGXs, but anyone inside of the SGXs can deploy their own searcher or builder code, and we sort of impose restrictions on them by nature of the SGX. And so you get no sandwiching, you get other properties that you want, like pre-confirmations, but still with permissionless competition as opposed to a proof of governance type thing, which is the alternative here.
There seems to be quite a lot more features and like levers that are in the hands of the L2 space because of the fact that sequencers and these block proposers are a lot more permissioned than on the L1. And it is cool to hear a little bit about the use of trusted hardware, SGX and what you were mentioning. Because when I had heard about the use of those technologies, it was primarily in the context of decentralized block building, but using that for, creating pre-confirmations, for creating, imposing more restrictions on the type of MEV activity that can happen. That's all new to me. Can you talk a little bit about one other product that obviously I've been hearing quite a bit about, and that's Suave, and also this idea of like a shared sequencing network? Like, is that another major product that is going to be that is going to change the game for how MEV is earned on rollups in the L2 ecosystem? Is it like one shared sequencer network to roll them all? To what extent is that like another major product that is in the horizon for the L2 space?
So I'll talk about Suave first, and then we can talk about shared sequencing as much as you want. Suave is...
Are they not the same thing? I thought they were the same thing.
Not quite.
Okay.
I think sequencing as a word has sort of been bent and changed several times.
Okay.
So we're all trying to say that we're doing sequencing in one way or another, but we all say a bunch of things. So Flashbots is more narrowly focused on block building and MEV. And sequencing has two parts, just like validating on L1 has two parts. It's first proposing, so adding economic weight to a block, and then second, what the ordering of that block is, and so block building. So when people say sequencing, there are two jobs there, proposing and building. Generally, shared sequencers refers to the proposing part. Can you share a proposer across many different rollups as opposed to the building part? And so shared sequencers like Espresso, as an example, or any of the other ones out there, they are trying to give people a shared proposer, but in order to enable that, you need a builder that is aware of multiple different blocks, and you need sort of a super builder almost that can build blocks across many different chains. But they're more narrowly focused on, as I understand, the sort of proposer part of the equation as opposed to the builder part.
Not the building of the block. I see.
And we at Flashbots are focused more on block building rather than proposing.
Okay, that makes sense. So the Suave chain is for building. It's creating that marketplace again for searchers and builders to create these very MEV-packed blocks, which are then proposed and sent over to, say, a proposing cross-chain network like the Espresso network.
Yes.
Okay.
Yeah.
Oh, well, okay.
We wanted... So Flashbots has run centralized infrastructure for quite some time. And at our heart, we are a company that cares a lot about crypto. We care a lot about decentralization. And so we wanted to decentralize that infrastructure. And what we came to is an architecture that allows you to program the use of trusted execution environments like SGX, like TDX, to do a lot of things that you can't do on chain, like block building. But really, it is a platform. Suave is a platform for really low latency, cheap, and private compute, which is what block building is. And you can see block building is one application on top of this platform, among other types of applications that you could run too.
Wait, like what type of applications?
As an example, we have a demo of a user minting in an NFT on some rollup, right? And they call out, as a part of that, the user makes a transaction on Suave that calls out to an SGX, which can make an HTTP request to an external service like ChatGPT. And so we have this demo where a user is minting an NFT on a rollup, and as a part of that, Suave, using an SGX, calls out to ChatGPT, queries it for some ASCII art. Suave returns that and injects it into the NFT, which is then minted by the user.
This sounds like a very performant, like Oracle.
Yes. Yeah.
That's so crazy.
It is a programmable, very performant Oracle in this case. And you can program it to make arbitrary HTTP requests. So you can call out to a Web2 server. As another example, we have a demo of running a Quake server inside of an SGX. And so you could program things like, I want to bet 1 ETH on this Quake match, and whoever wins the Quake match gets all of the money. And you get an actual guarantee that this is done correctly because it's done inside of an SGX too. And it just so turns out that kind of this fast, cheap, and private compute is what you need to decentralize MEV use cases like block building as well. But you get all these like nice other and interesting application use cases as a part of that.
That sounds very cool for what you're describing. Is there a timeline for when we'll see the Suave chain go live?
We have a testnet right now. We haven't been live about it or loud about it because generally when you're very loud, you get a lot of people who may not give you the most thoughtful product input. Let's put it that way.
He's referring to crypto Twitter.
That and airdrop farmers. It's just sort of harder to get signal on product market fit if you have a lot of people who are super incentivized to use your thing for reasons that may not be, inherent to your product value proposition. So
if you don't want the farmers, don't do points, okay?
So we've been iterating in a more closed setting with a testnet, but we have a testnet live, and we are talking to and working with a bunch of rollups, which is also a call out if you are a rollup team and interested. We're looking for early partners for our block building products for rollups right now. So I would expect to see something in the next coming months from us. Some announcements also at some upcoming conferences, things like that. I can come back on the pod. It's fine.
Okay.
But if I come back on the pod, you need to wear actual jungle-themed clothing.
I know. I'm sorry. No, that's so true. I do. I've been running. I was telling Bert before we started recording, but I do need to buy more jungle-themed attire because I've used them all up. Anyways, I will. And we will have you back on during those announcements. For the last couple minutes of the show, I do want to get really big picture with you. Bert, you have been working for Flashbots for now how many years?
A little over 3.
A little over 3. And when did you first start researching MEV?
Before Flashbots, I was an MEV searcher. So I did MEV on CryptoKitties originally. So whenever CryptoKitties was, 2017 or something like that.
So super early. And the landscape of MEV has changed so dramatically. We just talked about L2s, whereas I feel like when we first met, we were really just talking about the emergence of MEV on Ethereum. And now this explosion of kind of activity and different types of products that we've been talking about on the show so far are cropping up. I want to ask for a little bit of like a look back of the products that have been made to address MEV by Flashbots and other companies, and how the MEV landscape has changed. Based on the work that you've done in terms of the products that you're building and have built, is there anything that you would say you wish had been done differently to change the trajectory of what the MEV landscape looks like today? Of course, MEV has always been a controversial issue, and there are very loud voices on Twitter, some of those that are Ethereum core developers as well, saying that they really regret, making certain decisions for the way that the MEV supply chain looks for proof of stake after the merge. Just curious to hear your thoughts on what are your takeaways from the decisions that have been made to make MEV more decentralized and transparent. Is there anything that you wish had been done differently over the last, say, 5 years, however long it has been since DeFi Summer and since MEV really got on the map with the Flashbots paper? I mean, any kind of major learnings or things that you want to address and talk about?
Yeah, that's an interesting question. So our major product decisions and kind of retroing those, I think MEV in retrospect was the right decision. We made all the right decisions there. Ethereum did have a problem with spam. It did have a problem with chain usage. There were backroom deals that were going on. All of that was an issue. So MEV I have no qualms about, regrets about. I think even with the benefit of hindsight, I think we made the right decisions around MEV-Boost as well. At the time, we were trying to prevent additional centralization of stake from Ethereum's validators by allowing validators to outsource block production, so there's no kind of difference, or rather so that solo stakers were on the same footing as large pools. And I still think that reasoning holds. And I think if we didn't have MEV-Boost today, you would have the block builders that exist right now going directly to the large proposers, going directly to even solo stakers, and entering into these kind of trusted relationships with them instead. And you would have more pressure on solo stakers to roll up into pools as well. And so, I understand why people may not feel good about the current market structure. I certainly don't as well. But I think that this is the least bad path possible, and that MEV and sort of the centralization that exists from it is going to continue to be a centralization pressure, sort of regardless of the design choices that we made, whether we had MEV-Boost or not. And I don't see a better alternative path right now.
Well, hold on a second. We're both on the same page about being concerned with the way that the MEV supply chain is working right now. There's concerns about builder centralization, about, when closed source relays break down, what types of activities they're really engaging in behind the scenes. There's clearly, concerns and issues, and I think some of which are really making a lot of Ethereum core developers worried about the censorship resistance of Ethereum. But when you say that there's not a clear path forward or a clear path, clear
alternative, because
I feel like we need one, though.
Yes, I agree with that.
Have concern, Robert?
I agree with that. Yes. The interesting thing is that sort of all the things that people are pushing on today, like relay performance is one. You're hinting at sort of the vertical integration pressures, some of the exclusive deals that are going on, some of the unsavory activities from some builders, some relays, some order flow providers. All of these things were issues that we were aware of at the time of MEV-Boost. It's very funny, if you go to the MEV-Boost GitHub repo and you look at the issues, a lot of these things we were talking about almost 3 years ago at this point, or talked about in the GitHub issues. Timing games, all of that, it's in there, actually. And even still, we can't turn off MEV at this point, right? So if everyone stopped running MEV-Boost, or if all builders and relays didn't exist today, and we removed the builder API from these clients, people would still want to get MEV revenue. Somehow, people would still make deals with builders. This activity would happen. The alternative is not that it doesn't exist. The alternative is that it is even less transparent than it is today.
Yeah, I'm totally.
And I think we are building towards better solutions. Flashbots has been trying to do that for some time, and there are ways to address these problems, but they're very hard problems, very hard distributed systems and engineering challenges, very hard sort of coordination problems that exist. And so I'm not saying that there is no path forward or no sort of light at the end of the tunnel. I am saying that I don't know that there's a better alternative to MEV-Boost itself.
To MEV-Boost, at least right now, at least based on the current research, there's not a clear path forward that improves the state of current affairs for MEV materially. And that's something that Flashbots and people are still working on.
I would challenge at least your statement that there's not a clear path forward. I feel like there are things that we could do, but I think on the level of MEV-Boost and having a full block building market that is accessible to all stakers, I wouldn't take a different trade-off there.
Right.
That is what I'm saying. There's not a clear alternative, right? So we could fall back to something like a MEV-Geth style market, which existed in ETH L1 before the merge with proof of work. And then only Lido, Rocket Pool, Coinbase, Kraken, and Binance get MEV, right? And all the solo stakers have to work with their much lower returns than what exists at pools. And then there's a pressure for people even more so to convert and stake with those pools as well. And I just don't think that is the trade-off that I would make relative to keeping MEV-Boost and trying to iterate on that market structure. But I do think that there are things that we can do to improve the market structure of MEV-Boost and PBS more broadly on Ethereum today.
Yeah, I mean, and I know, final question, because about that point, I do really want to look ahead to some of the things that I do believe, that you believe is going to improve things on the L1. We talked a lot about the L2, but obviously the L1 is really supposed to be the fundamental kind of like most decentralized layer that upholds this modular tech stack. A lot of developers are talking about enshrined PBS, issuance changes, talking about the impact of restaking, potential inclusion lists. There's a lot of different research going on to try and improve the state of things on Ethereum and the problems that we've talked about in the MEV supply chain. Which of those, if not any of those, or something else, do you think there needs to be more research about, and is one of the most promising when it comes to improving MEV-Boost?
So my answer is none of those, actually. And I'm going to take it in a different direction. First, about something that needs more attention, not because it's promising, though. And then I'll talk about what's more promising.
Okay.
So
hit me.
What I think needs more attention is the financial gravity, so to speak, of latency in these systems. And so the MEV market is so competitive these days that 1 millisecond can give you an advantage as a relay or as a builder. And you have several highly incentivized parties that are trying to iron out every possible millisecond of latency in their systems. And what this does is it puts a pressure on everyone. The reason is that every individual bit of time that you have gives you more time to build a block. It gives you more time to take transactions from around the world. It gives you more time to arbitrage against centralized exchanges on chain, right? And so there's money to be made by making things faster, basically. But since there is this money to be made by making things faster, the incentive is for everyone to co-locate, to be in the same data center. And that means not just builders and relays, but that means proposers as well. And so there's kind of this gravity from the money to be made from latency, what I called financial gravity, that is acting as a centralization force to put everyone in the same data center. And if you're in the same data center, then you are in one geography, and you are subject much more to that single geography's regulations and whatever their compliance requirements are. And it ends up being you get much more exposure to a single geography. And in particular, I think at the limit where this manifests is wherever the centralized exchanges are. And so you can imagine a world where everyone just co-locates with Binance, because that is where the majority of centralized, decentralized exchange ARBs come from. And everyone is just in the same data center as Binance, all the builders, all the proposers, all the relays, because they make the most amount of money there. And then wherever Binance and their servers are located in whatever jurisdiction, there's a massive more amount of exposure to the compliance requirements of that jurisdiction.
That's a concerning future, but I can see how the dynamics do kind of lead to that.
Yes.
Yeah.
Yes.
Because latency is the name of the game.
And this matters a lot in the context of these really high performance rollups as well, because if you want these things to be really performant, and at the same time, you want them to compose and to talk together in something like a shared sequencer, you want interoperability between them, then the natural thing to do is to co-locate them on one server as well. And so you again have this sort of financial gravity by trying to push things to the limit, and because of latency and the money to be made from them, or in this case, I guess, a product experience that we want to offer, interoperability. And so I think a lot more attention needs to be paid to geographic centralization and the financial gravity of latency in particular.
And now what's the promising practical solution to that you're about to drop on us?
Yes. So we have been hard at work trying to optimize building blocks and more generally MEV infrastructure inside of trusted execution environments. And so right now, actually, Flashbots has a block builder inside of TDX that is building blocks on mainnet and is reasonably competitive. It's in the top 10 for block builders. And we're not playing all the games that everyone else does, right? So we're not paying thousands of dollars in subsidies every day to get up on the leaderboard. But it is as performant actually, as performant. We have no performance loss, essentially, from the trusted hardware overhead, which is really promising. And this is a really interesting building block because we can use this as the basis for a decentralized and distributed block builder. And you may actually be able to architect this in such a way that it is faster to do things in a distributed setting than it is in a centralized setting. And that is what I think is really promising about this general direction.
I'll see it when I believe it. Or like, I'll believe it when I see it. I said that mixed up, but the fact that a decentralized setup could be faster, I think that's kind of crazy, but also very exciting to hear about. Well, thank you so much. Thank you so much, Robert, for coming onto the show and for sharing a lot of really exciting and cool products to be looking forward to, I think, in the next few months.
Yeah, next few months. Thanks for having me. Really appreciate it. And thanks for the conversation. Yeah.
And thank you so much to everybody who was listening to this episode of Infinite Jungle. We hope that you have learned something new about the Ethereum space, about the Ethereum ecosystem. That is what we call the Infinite Jungle. And we hope you'll tune again for the next episode. Until then, stay safe out there, everyone.